Mathematical logic, mathematics in a modern world. Mathematical logic is the study of logic within mathematics. Major sub-areas include modal theory, proof theory, set theory, and recursion theory. Research in mathematical logic commonly addresses the mathematical properties of formal systems of logic, such as their expressive or deductive power. Logic statements and quantifiers. Logic statement is a declarative sentence having truth value. Examples: today I have math class. 1 plus 1 is equal to 2. Quantified statements are words that describe an entire set, such as all, every, or none, are called universal quantifiers because that set could be considered as a universal set. In contrast, words or phrases such as some, one, or at least one are called existential quantifiers because they describe the existence of at least one element in a set. Examples: all dogs are poodles. False. Some books have hard covers. True. Truth tables and tautology. A truth table shows how the truth or falsity of a compound statement depends on the truth or falsity of a simple statement from which it is constructed. So we'll start by looking at truth tables for the 5 logical connectives. A tautology is a formula which is always true. That is, it is true for every assignment of truth values to its simple components. You can think of a tautology as a rule of logic. The opposite of a tautology is a contradiction, a formula which is always false. In other words, a contradiction is a false for every assignment of truth values to its simple components. Conditional, biconditional, and related statements. Conditional considered 2 statements, P and Q. If P being true always leads to Q being true, we have a conditional relationship. If a conditional statement is false, if hypothesis is true and the conclusion is false, the example above would be false if it said, if you get good grades, then you will not get into good college. If P is true, then Q is true. If P then Q, P to Q, C, Warner, and Connenable for other equivalent phrases, these all say the same thing and have the following truth table. P is the antecedent of hypothesis. Q is the consequent or conclusion. Biconditional is when a conditional statement and its converse are both true. The 2 statements may be combined. Use the phrase if and only if, sometimes abbreviated IFF. Statement: if an angle is right, then it has a measure of 90 degrees. Converse: if an angle measures 90 degrees, then it is right angle. Biconditional: an angle is right if and only if it measures 90 degrees. If-then statement is when we previously discussed inductive reasoning, we based our reasoning on examples and on data from earlier events. If we instead use facts, rules, and definitions, then it's called deductive reasoning. We will explain this by using an example. If you get good grades, then you will get into a good college. The part after the if you get good grades is called a hypothesis, and the part after the then you will get into a good college is called conclusion. Hypothesis followed by a conclusion is called an if-then statement or a conditional statement. Arguments and Euler diagrams. Logical arguments. A logical argument is made up of premises, assumptions, laws, rules, widely held ideas, or observations, and a conclusion. Valid and invalid arguments. An argument is valid if the fact that all the premises are true forces the conclusion to be true. An argument that is not valid is invalid. It is called a fallacy. Arguments with universal quantifiers. Several techniques can be used to check the validity of an argument. One visual technique is based on Euler diagrams. Right now, I am going to explain to you the example. All cows like to chew. Some dairy animals don't like to chew. So, we need to put the cows first and encircle it out. Then, things that like to chew and encircle it together with the cows because it said that all cows like to chew. After that, we put dairy animals. Encircle it with cows and things like to chew but make it half because some dairy animals don't like to chew and some cows are dairy animals. In the next diagram, we must put cows first and encircle it out like the other one. Next, things that like to chew and encircle it out because it said that all cows like to chew. After that, we put dairy animals and encircle it but connect it just the things like to chew because some dairy animals are not cows. It is not possible to deny the conclusion. Some dairy animals aren't cows. Thank you for listening. I hope you learned a lot from us. This is the mathematical logic from Mathematics in Modern World. Thanks for dropping by.